Today I'm going to explain hill climbing algorithm and linear programming implementation in Python. So let's have a look at hill climbing first. So in this Python class we have class namespace, which is our state space, and here is the height and width of the space given the number of hospitals and a set of houses and hospitals to keep them. We have a function for adding house and also looking for available spaces which we can use to put hospitals at random places in our space. So this is our main hill climbing function. So first of all, the hill climbing starts at initial state. So it actually first initializes all the hospitals randomly in our space. So then we print our initial state using the log. So then we print our image of our initial state. So here the actual loop begins of the algorithm. So first of all, we iterate through a maximum number of states, which user can provide or cannot. It's optional. So in this for loop we pick a hospital in a hospitals set which was initialized randomly previously. So in this hospital we consider our neighbors and get all the possible combinations of the hospital neighbors. So then we check for if the cost of the neighbors are better or not. So if if best neighboring cost is greater than or equal to the current cost, we can simply return the current hospital. Then we can print if we found a better neighboring cost or not. Then return the set of hospitals, and then we output our image of the manipulated states. Then we continue the loop. So let's have a look. We currently have a function called like a hill climb, which is our function. So we're going to run this. So s dot hill climb. Let's have a look. Hospitals, enter. So this is our optimum solution given the number of iterations we had. So this we can see the hospitals are optimally placed where all houses can access easily. So here is another kind of hill climb algorithm called random restart. So if we look at it, we can see we call hill climb multiple times in our number of hospitals, because which is already randomly organized. So then we compare the cost, and we print if there is any new state cost or a new state or not. Then we simply print the output image, then we return the best hospitals. So if we run this hospitals, yes, then here we can see it simply found a new best state at the cost of 54. Then it found nothing best, then it got to 41, then 47, and because it simply picked the random pot in our space and iterated through it. So this is a hill climb algorithm. Next we're going to look at linear programming. So in linear programming we represent our problem with a linear equation, which is a cost function, and we try to maximize or minimize the cost function according to our problem. So here is our cost function is 50x1 plus 80x2. So we use the linear programming function or method from SciPy optimized library. Then we simply pass the cost function's coefficient, which is 50 or 80, as a 1D array, and the coefficients of inequalities as a 2D list or array, which is 5, 2, and 10, minus 10, minus 12, and we set the upper bounds as a 1D array or list, which is 20 and minus 90. So if this linear programming method successfully solves this equation, then we simply print the cost or the hours they work in our console. Otherwise we got no solution. So if you see this, here you can see we get x1 is equal to 1.5 hours and x2 equals 6.25 hours. So this is about linear programming, and thank you.